Okay, hi everyone, I'm Brendan, and I did a prayer to live God demo, so you should be able to see Richard behind it. So it's working. So this project started off in the summer, where on yet another video conference call, someone was sitting in their back garden, and I was thinking, why are you sitting in your back garden? You'll never be able to see anything on the laptop screen. And then I thought, well, it'd be really nice to have a screen that was e-ink. But the cost of e-ink screens were pretty high. So I kind of parked that for a while. And then my son got me to get him a HDMI capture card. I thought, wait a minute, I've got a Kindle, I've got a HDMI capture card. Why can't I start putting those all together? So the project was born. In the end, I've got an OK monitor, which will take a VGA input, give me a resolution of 124 by 748, and depending on how many screens I've got, gives me 5 frames per second or 6 frames per second, and it's wireless. So I call it an OK monitor. In the monitor is HDMI capture card, a Pi. The Pi is acting as a wireless access point, and then that goes to the Kindles for display. So that's it. Kindles, Raspberry Pi, HDMI capture card, plus some bits and pieces. And the software, I'll go into more details in a bit, is OpenWRT, which is, I think we're embedded Pi software system today. So this is another embedded system. And then it uses FFmpeg, something called Geek Master Video, and then some Kindle stuff. So let's, and it operates all 4 on one screen. So let's give you, so on the Kindle, you just plug in the cable on the Kindle, launch it, and then the Kindle starts up, and that's it. You've then got an extra monitor, and I'm just changing the resolution to a better resolution. And so that's it. It's just an extra monitor on there. There's a bit of a lag, and I'll explain that a bit later. But from that point onwards, you've got a wireless monitor. You can do some web surfing on it, or another bits. And that's a web page of the person some of the software I used. And if you to test the video calling or listen to a video conference, you can even run, even watch a little bit of video on it. So that's it running. I'll just dive into a bit more. Close up on the Kindle, it looks like this. That's it. At this point, it's just the monitor acting as a pure monitor connected display. The grey scale, some compromises need to make on the grey scale, so the contrast is not as good as can be. But if I'm using it in the sunlight, that makes up for it, because it's a proper e-ink monitor at that stage. You'll see some ghosting on there, and I run it so that if you touch anywhere on the screen, it'll do a full refresh, which takes slightly longer. But then that's it running with the video on. So let's jump into the detail of how I got this all working. So mention the hardware again. So the Kindle is an absolute monster. It is really good. And I have not developed a Kindle fetish and not got lots of secondhand Kindles from eBay and CX, honestly, but I do own more than 4 or 5 or 6 now. Kindle One, the Paperwhite One. It's about 37 quid secondhand from CX. It runs Linux, and the battery is stupidly, amazingly long, even for secondhand Kindles. The Kindle One is really good because it's the latest firmware. Even the latest firmware release, you can still jailbreak. So I don't have to worry about opening it up. It's all quite good to jailbreak. Takes around 20 minutes. It's really easy. No soldering. As someone who can't solder, it's really useful. And then you can put a Kindified unified application launcher on that, which just allows you to put in it. It opens up as a Kindle as a book, but you can. It's a menu system where you can launch applications from your custom menu and run your own code on the Kindle. Next bit of hardware was the Raspberry Pi. Raspberry Pi is a beast of a Pi, although it doesn't run Roblox on Android, which I originally bought it for. But its processing power is really, really improvement compared to the other Raspberries. It's quad core, which is quite important. HDMI to USB adapter. These are really cheap and really good. And I've just stuck a HDMI to VGA to HDMI adapter on the beginning of it, so I can get VGA input. The only problem with the HDMI adapters is it adds a bit of lag. So this is a test I did where I played a video on my laptop with I edited the video to give me a frame by frame timestamp on, and then I connected the HDMI USB capture card back into the laptop and then played the video that was capturing. So the difference between, so I'm capturing the top left hand of the screen and then playing it the top right, and even with a fast laptop, I'm getting 0.8 of a second lag. There is a really good device which I've just got, which allows you to capture the HDMI straight into the Raspberry Pi port, which I think Christian's just mentioned on there. I haven't tried it yet. I would save about 200 milliseconds on that. That's probably my next upgrade on that. The HDMI capture card comes in as video for Linux. The reason why it needs to be a Pi 4 rather than a Pi 3 is I could get the HDMI capture card to capture USB thing to do MJPEG, but it doesn't look very good, and it adds even more lag to it because you've got the JPEG artifacts. But for the Pi, I need the Pi 4 because I'm in effect reading raw pixels, which is quite difficult to then process. So the software, this is software where it gets fun. I'm using OpenWRT, which is really good. It's fast. It boots really fast. It allows you to set up access points really easy. So the Kindles there are connected to this access point here. And there's loads of packages available. It's a really good embedded system. There's about 18,000 packages available. Everything's done as root, and you just update the package list and then install the package. I've made a specific image for this system to load on the Pi and compress down. It's only 56 meg. And you plug it into the Pi, boot it up, and you've instantly got an access point called OK Monitor. And it's headless. There's no keyboard or anything I need to control it. It's all controlled by the Kindle. The glue I've used to make it headless is Netcat. I've never used Netcat until this project, but it's lovely. It's really good. And and it does exactly what it says in the tin. It's like using the cat command, but across the network. It's really good. The Kindle, it's quite an old Linux system that's on the Kindle, but it has got Netcat inbuilt. So, which is a slightly old version of Netcat, but a few peculiarities, but it's there and you can use it. I can get Netcat on the Pi quite easily, and then I can push data backs and forwards on that. And what happens, I get the Kindles to pull the SSH key from the Pi, and then the Pi can SSH into the Kindles. And then from the Kindle menu, you can configure the monitor, which monitor is monitor 1, which is monitor 2, which is monitor 3, which is monitor 4. And then I can just use the Kindle to start the rebroadcast of the video stream. What I didn't realize at the start of this project is how intensive pixel by pixel video encoding is on the CPU. Or my C is really poor, or both. I kept testing things on the laptop, and then when I tested it on the Pi, it didn't work, and I was kind of scratching my head why it didn't work. But a utility I used, ATOP, which is a really good version of Top to see how process is running, but basically the Pi 3 is just not up to the job. Because the Pi is quad core, I can split the video and process each quarter of the video by one core at a time, and then use that and Netcat to send to each Kindle. I've got some background noise just come up. So what I do is set up 4 pipes. Yeah, someone said in the chat, someone's turned on their mic. There we go. Thanks. Set up 4 pipes. I make 4 pipes, and then each pipe I set it up so that any data coming into the pipe goes to the encoder, and then is available, and then Netcat squirts it out to whatever's connected to Netcat. And then the wonderful FFmpeg takes the video input from the capture card, splits it, makes it the right video size, converts it to grayscale, and then splits it into 4 each quadrant, and each quadrant is encoded as raw pixels and sends it to that pipe. My FFmpeg command kept getting longer and longer and longer, but this is what it ended up as. This is a shrunk down size of it. And then the encoding and the decoding of the video is something I borrowed something open source. Geekmaster Video released it back in 2012, and for the Kindle that will play video that's pre-encoded for the previous version of Kindle at 7 frames per second. I edited it and modified it to take it at 512 by 379, which is a quarter of the standard 1024 by 768, I think it is. And that encodes it to the raw Kindle, to a raw Kindle format, and then on the Kindle, Geekmaster Video plays that. I tweaked it so in the setup behind me, each pixel sent is actually written to 4 pixels on the screen, but in the single version one running on this, each pixel writes to 1 pixel, but I've had to have 4 encoders, decoders and encoders running at the same time, because anything more than that the Pi can't handle, and the Kindle doesn't handle that well. So that's it. That's how we get an okay monitor from either one Kindle can run it, or you can have it in that setup where you've got 4 Kindles running at the same time. And that's it. That's it. Any questions?
So you're grabbing the video from your PC and you send it over to the Pi, and the Pi send it over to the Kindle.
Yeah.
Okay.
But in effect, I get the laptop just sees a monitor connected.
Yeah, I didn't really get it, but what do you have on the Kindle to kind of capture the video and stream it out? Is this geek? Is it geek stuff or?
I just have on the Kindle, the data stream comes in to a application which writes directly to the frame buffer on the Kindle.
Okay, sounds cool.
So I kill the Kindle's got a front end program. You just kill that, and then you've got a raw frame buffer. You can just write the bits to directly.
I don't know if you've seen, but there is also like a Kickstarter that works over ESP. Like they're trying to make this ESP Kindle size. It's kind of cool. Maybe you can hook it up later.
Yeah, I've seen it, and but I think it was a driver board to drive the Kindle screens. But what I wanted was something that gave me a monitor. Kind of, the lag's the problem. The lag is a slight problem, but I wanted something to give me a monitor feel.
But imagine maybe like if you can use that one, it has an ESP inside it. You can just grab the frames and then convert it straight away to the screen. So maybe you can maybe cut off some of the processing and we stream it a bit faster in a way.
Yeah, I've got the Pi in effect adds like 400 milliseconds to it. But for the encoder, but yeah, there's it's livable to read this stuff. It's livable to watch some stuff on the outside, but yeah, it's not, and it's an okay monitor. It's an okay monitor. That's the concept.
You can use a CCTV camera as well. Like it's kind of like a cool,
Yeah, anything that gives me a camera feed, be it HDMI or VGA, I can just put plug it in, and then I've got a wireless monitor as well, so I can kind of hang it up anywhere.
Do you use the touch functionality on the Kindle by running all this stuff, or?
Yeah, I've still got the touch, and I use the touch to give every time I touch the Kindle, it gives me a full screen refresh.
But the Kindle itself doesn't have like a X and Y touch.
Yeah, it does. It does. Annoyingly, I've got 4 versions of. So I started using Paperwhite ones, but each different version of Paperwhite has got a different way of accessing the touch control, and each firmware version. So I can either standardize on like Paperwhite 1, which I did, and I got all the touch working, and you can get the touch working quite well. But then when I started to run it on different firmware versions, like because Amazon block you from registering an old firmware version as a proper Kindle, their software API keeps changing. So, but anyway, there's a little bit more I can do. But yeah, there's some really good code examples on the mobile forums, mobile read forum, to accessing the touch coordinates.
And it's also have like you create maybe an application on the Pi, and then you got a monitor that shows maybe the GUI wireless, and then you can use a touch to create, press the buttons and so on. That would kind of be cool.
Yeah, definitely. You can definitely get that feedback. I could probably do it as a touchscreen mouse or something like that, but kind of proof of concept. What was the name of the access point software? OpenWRT.
Thank you, because that's like one of those things that I've been meaning to play with for some of the things I've been dealing with at home, and like I never got it to work reliably.
So
for
that's the same
like
software.
having out the Nexus point.
Yeah, that's the same software I've got on my main router at home. It's really documentation is not good, but the fun if you use OpenWRT can come with a GUI as well, and you can even run it on a Pi Zero.
Yep.
When I was playing with the kites after you do it, I put OpenWRT on a kite as well, and you can get an access point really simple. You just put you change one config to set the password up, and that's it. One config file.
Oh, that's awesome. Okay.
Yeah,
that's cool. That's exactly what I'm going to play with. Okay, awesome.
Yeah. I've got the software's linked so you can kind of have a play with the image as well.
So what's your recommendation for a Kindle to use?
Paperwhite, the Paperwhite one, because even if it's got the latest firmware, you can jailbreak it. But since I've now got the habit of bidding for random Kindle Paperwhites on eBay, I got 2 recently, and the Paperwhite 2 will work as well. And once you jailbreak it, you can then take it to the latest firmware, and the jailbreak still remains. But Paperwhite 1, I mean, I've got anything from 11 quid to the maximum I paid is 36 pounds from CX, and then if you get then CX, you just post it back at their cost as well if it's broken. So you kind of come with some guarantee. But yeah, eBay 10 to 30 quid, really good to play with. Yeah.
How are you going to extend this project? And are you planning to do anything else, or is you?
I want to try and get to 9 screens. So I've only got I've got 4 screens before, but I think if I can get to 9 screens, that'll make a kind of like an 18-inch monitor, which would be really good. But unfortunately, the mass doesn't quite work, and I may have to go to 16 screens. So don't bid on any eBay Paperwhites at the moment. You'll be bidding against me.
What sort of battery life do you get from a Kindle if it's wirelessly picking up as acting as a monitor?
I haven't run out. Oh, there we go. Typical. It just crashed. Excellent. Never done that before. I've got at least a couple of hours out of it from a fully charged one. It's because the Kindle's kind of battery's measured in days. I think I just pulled a plug somewhere. I might have to do a reboot. Because the demo god caught up with me. I've had it running for at least like an hour and a half, an uncontrolled test, and it was running fine without having a battery, without the battery running out. So
cool.
I need to do a proper battery test at some point.
I guess it's how intensive is the application you're viewing. If you're viewing a video, it's going to be changing pixels a lot. If it's a screen, not so much.
The way I've done it is that it's a full frame. Every frame writes the full, so it doesn't matter. I could probably start doing it so it only updates the difference and stuff like that. But it was I did something quick and dirty. Yeah, it was quick and dirty, and it only updates every frame. So for the full frame version, every Kindle 6 frames a second. But the Kindle battery is just madly amazing. Yeah.
Good. Yeah, fascinating. Cheers.
Have to redo it. No. Okay.
Sorry, any other questions?
I've got a follow up. Would it be possible if I didn't use a video capture card just to get the Kindle to display the Raspberry Pi screen?
No.
Oh.
No. You can get the Kindle. You can get the Kindles. You can SSH into the Kindles and display images. Actually, wait a minute.
But
Yes, you could. Yes, you probably could. I mean, other people have done it with VNC.
Okay.
And there's a VNC client that runs on a Kindle. You could get FFmpeg to capture do a screen capture of a Pi, yes. And probably
yeah, the inputs only changes.
Probably doing it, yeah.
Instead of like the capture card is going to be your screen.
yeah. The capture card's only capturing a video screen, but if you point FFmpeg at the screen, it could capture the screen directly, and then it jumps out that capture card. Yeah. Nick, you've just recommended what I can do on version 2.
Oh, brilliant.
That's good. That's kept me another couple of months of lockdown busy. So that's good.
Well, just listed there. This is a fullback to capture actually screen on Linux. I don't know if it works on Pi as well, but that's basically the command to capture, your screen and record it into like an AV file.
Oh, sounds fascinating. I've got, I'm sure like everybody else, I've got Pi sitting there running applications. It would be nice just to be able to stick a screen on it, just as a status update, whether it's plain ADSB plane tracking or balloon weather balloon tracking. You could just have these dotted around all over the place.
Oh, the Kindles are great for that. You can set the Kindles as cron jobs to go to sleep and then capture. So when the Kindles are not being used like this, I've got the Kindles just display photos. So they wake up every 5 minutes, grab a random photo from my library and display a photo, and they last for about a month on that. So you can they're really the Kindle is I annoyed I didn't realize you could hack Kindle so easily before. So yeah, but no bidding on eBay against me.
I'll go off to the window at CES and see what they've got.
Yeah.
Cool. Any other questions? All good? Well, thanks very much, Brandon. That was really quite unusual. Wasn't expecting that one.
Okay, cool.
Thanks a lot.
Check out. There's more. All the source codes available, and some more detailed setup instructions are on the website. Referenced.
Excellent. Thank you very much.